Hello everybody, my name is Logan McCoy, and today I will be speaking to you about phosphate mining. So before we actually get into the entire presentation, I'm just going to be giving you a brief overview about what I'm going to be talking about today. So first off, we're going to start with obviously what is phosphate mining? Why do we do it? What does it give us? From there we'll move on to how is it done? So what's the process? What are the steps taken to actually finally extract this phosphate from the earth? And then one of the most important things is what risks does this have for us? What are its effects on human health? What are its effects on the environment? Is this mining detrimental to us? Alright, so starting off with phosphate mining. Phosphate mining is quite obviously the mining of phosphates. So why do we do this? Well, pretty much the major reason is phosphate is a very important fertilizer. It's a very important food source for many plants. I keep saying very, it's extremely important in converting the sun's energy into food for these plants. In today's day and age, that's especially important with the rising global population. We need better ways and more ways to create food for all these people that we have. And phosphate is, like I said, a tremendous help in this because it's such a good fertilizer. When phosphate is introduced into the system, it becomes pretty much the limiting factor for how much the plant can grow. So the more phosphate you add, in general, you can keep increasing the plant growth with as much phosphate as you can provide it. So obviously it's a very important factor in this. Alright, so the process for phosphate mining isn't the most complicated. It's pretty much what you would imagine. So phosphate is found 15 to 50 feet below the surface. One of the major mining sites for this is right here in Florida. So the first thing we do is remove the overburden. So the overburden is that 15 to 50 feet of sandy layer that's right above the phosphate. And so what they do is they remove the overburden using electrically operated drag lines, placing the overburden in these large buckets. The drag lines remove the overburden and deposit it into previously dug holes, possibly from other excavation sites used to remove phosphate. From there, they remove the matrix, which is the sandy portion that contains the phosphate that we're trying to remove, and it excavates that and deposits these areas into a containment pit or a slurry pit. So once in the slurry pit, what they do is they blast it with highly pressurized water, and this helps to break up the large clumps to pretty much get it as finely ground down as possible. And from there, you can take that watery mixture and easily transport it to a processing facility or a beneficiation plant where the phosphate rock is physically separated from the sand and clay in the matrix. The slurry is moved through many washing stations and separation filters once it gets to that actual center. Excuse me. So it removes the phosphate, and then it takes a lot of the clay, which makes up a large portion of what the phosphate matrix is, and they're able to pump these back out into ponds and reservoirs, which that water is then used again and again. And companies such as Mosaic, which is one of the largest phosphate mining companies around, use up to 90% of the water that they recycle. Therefore, they keep a lower carbon footprint. They have less of a risk of contaminating the groundwater. And also these clay ponds and these reservoirs where they hold this water and clay deposits can be home to a large amount of wildlife, so it actually helps support local ecosystems as well. So from there, after we've removed all that, the smallest particles of clay and phosphate are further separated in another plant. The sand is returned by a pipeline to the mined area to be deposited back to where it started, and the phosphate concentrate is able to be removed and then sent to a fertilizer manufacturing plant where it's actually made into the phosphate that is more helpful to the plants, where it can be combined with other sources of nitrogen to provide even more food for the plants. All right. So just like with anything else, you're going to wonder, what are the hazards of this? Well, during the mining process, you dig up some radioactive compounds and other heavy metal elements, such as radium and thorium. Now, normally these aren't a problem because the 15 to 50 feet of ground separating it from the surface pretty much filters out all the radioactivity, prevents the surface from being harmed by it. Well, you're digging all that up when you're doing this project. So that's always going to be on the surface now until it's reburied or improperly disposed of. Now, there have been some studies done on this, but really nothing conclusive about how harmful to human life it can be. Obviously, any radiation that can build up over time can be very harmful to the environment. That's why there have to be major steps taken to ensure that none of these elements are mishandled or can get into a groundwater reservoir, which leads into the next point, the contamination of water sources. So during this whole process, things need to be properly contained so that you don't have that leaking of the heavy metal elements such as the thorium or the radium to contaminate our groundwater sources. Usually they're pretty well handled. There's many strict protocols and safety guidelines about how to handle this hazardous waste to keep it from contaminating groundwater sources. Another effect that you wouldn't think of right off the top of your head would be the change that this has on the landscape. So because we're in Florida, and Florida is a typically flat expanse of land, digging these massive holes into the ground can have a pretty significant impact on the topography of Florida. So you have these large craters that can be caused during the strip mining process. Before the strip mining process, water would be able to flow down towards wetlands and creek, making its way into rivers, eventually meeting and mixing with the coastal seawater. During mining, however, a lot of the water is captured at the mining site to keep the pollution from washing downstream. So that causes less of the fresh water to actually run down into these streams, and you get these large buildups of man-made lakes or ponds all along these sites. And even once the land is reclaimed, you can see the changes. The areas will be hilly; it won't be as flat as when they started. You'll have the artificial lakes existing where they did in nature, and because there's the clay settling at the bottom of these lakes, they don't function like natural lakes. It's impossible for the water to seep back into the ground because of the thick clay at the bottom. Therefore, it prevents it from recharging our drinking water supply. And as I said before, it doesn't flow down to the wetlands. So those are pretty much the main hazards. It's usually a fairly safe process, one of the less dangerous ones that we encounter. But that's primarily it with this presentation. Sources that I used, a big one was the Mosaic Company, especially the Florida part of it. They have a lot of the sources that I looked at that primarily related to a lot of the mining that goes on in Florida, and it's very well documented. So now I'll be taking the remaining of the time to have any questions that would be here. Unfortunately, because I'm not able to be with my group to give this presentation, I can't actually field any of the questions. I thank you for your time and hope you learned something enjoyable today.